Good day, everyone. My name is Shahrokni from SystemWeaver. Let me see if I can start the video as well. So for a few minutes, I know some of you who are here, we have worked together already, so good to see you. Maybe we wait a couple of seconds and then start with the webinar. I will turn off the camera soon once we start the presentation. So as you can see, yeah, your microphones are already turned off. And if you have any questions during the webinar, you can ask them in the chat. And if we have some time over, we can also take audio questions at the end. In that case, you can raise your hand as you see on the slide. Yes, so we are recording also, so you know. You can't hear, Cesar? Is it low voice or you can't hear at all? Can you check your set? Cesar, yeah. Cesar doesn't have his audio, and also Magnus. So maybe you can write something that they need to turn on their audio. Very good. Yeah, I think Cesar has his audio on now. Yeah. And Magnus, I see, has the same problem. Okay. So maybe we should get started because we have 1 hour and quite a lot of content. Okay, Cesar is good. Very good. Okay, so I will turn off the camera and start the presentation. So today I'm representing SystemWeaver, and we're gonna talk about the functional safety solution that we have in SystemWeaver. Just an overview and the general flow of things we're gonna discuss. So if you want more in-depth questions, I saw that some of you wanted to see something about tool qualification and other aspects that we might not cover today. So you're welcome to contact us later after this. And we're recording, so we try to make this webinar available online as well. So if we look at the company SystemWeaver that I'm representing today, it's a company that has been working in the automotive industry for 20 years with data management in the domain of system development and embedded systems, and very much also in the automotive industry with the I don't know exactly how many customers we have, but quite a few OEMs and tier ones, and also other suppliers are using SystemWeaver to manage their data. So the idea of starting SystemWeaver came from the complexity increasing in the automotive industry and the need to manage this complexity in a way. So the founding principles of SystemWeaver is that you want to be able to manage the data in an integrated way. So try to avoid information silos as much as possible. And then decrease complexity through providing means to manage the complexity. And one other basic principle is that to avoid the silos and also confusion of where the data is stored and what is the latest data in any domain, then we have this one single source of information as a grounding principle as well. And also when you look at the architecture of the platform SystemWeaver, it is a programmable meta model where you can develop tools, and Systemite is offering a lot of tools, but also the customers can develop their own tools by configuring the platform. An open API to integrate SystemWeaver into the tool chain of the customers, and also very importantly that it is collaborative, so you're not working in isolation, but rather the data is available in a collaborative platform, and you see always up-to-date information. And I guess many of you have already noticed that the demands in the industry are increasing. We have more development teams now than ever before. We're working agile. We want to do continuous integration, and at the same time we have a lot of requirements from different standards and government and so on that we need to comply with. So the complexity of the product itself is increasing a lot with more advanced ADAS and AD functionality coming in. And the scope of what is covered by software and electrical and electronic functionality in vehicles, this is increasing. And at the same time, we see that when the data is not managed in a good way and scattered between different tools or different files, this creates an even additional complexity because of not sufficiently good management of data, and it creates inconsistencies. So traditionally, the data is managed in different tools. Well, the tools, maybe different tools is not the main principle here, but in different kind of silos, you can say, like different files that are not connected to each other, and the data itself is not traceable between these information holders, whether that is a standalone tool or it is a file. And then keeping track of this traceability, even if it is established, is a very difficult task. Because as soon as you change something in one specification, then you need to go and change the references and wherever that piece of information is kind of traced to. But the way of working with SystemWeaver, the ground philosophy is that you have one data model with certain rule sets that are defined by each company, and you have integrations with different tools, two-way or one-way integrations. And what you then do is that you generate different views of this data, different specifications or documents or graphs or whatever, however you want to represent that data. So if we look at this dimension of the configurability of tools, usually traditionally it has been that you have tools that are for a very specific purpose, and then the companies needed to adapt their processes to this tool. This is a more traditional way, but now we're going more and more towards flexible tools that you're able to configure, and actually it doesn't, these tools shouldn't be an obstacle in the evolution of a company, but rather they should adapt to when the business model of a company grows. And SystemWeaver is somewhere there, more towards the flexibility, which means that we have, as you will see today, there are ready solutions, for example, for functional safety, which then can be configured in the context and the work process of a customer when it is instantiated. So you can use the experience, this 20-year experience as a starting ground, and then develop and adapt those solutions to your company's needs. So if we now look at ISO 26262, I guess most of you already are aware of this, that it is a huge standard which more or less has an opinion about every aspect of development in the automotive industry. As you see, many different phases are covered: concept phase, system development, hardware development, software, and also the supporting and management processes as well, and verification. It has 10 sections, 450 pages, hundreds of activities, and work product need to be produced. And today what I want to talk about is it's more like a hands-on webinar, not generally about ISO 262, but one way of handling it that we have set up in a demo database here. And this demo database is assuming, of course, a kind of a company structure and a business logic that I'm going to talk to you shortly about. So where we have features, different features, like today we're going to talk about the adaptive cruise control, very simple example, how you can do a hazard analysis, risk assessment, and then how you can make sure that the safety goals that are outcomes of the outcome of the hazard analysis risk assessment will be reflected in your design, both the functional design and then the technical design. And also how, when you set these requirements up here, how do you make sure that both you have traceability between the refinement of the requirements, but also how you have traceability between your verification activities and the requirements. And also another aspect is that you have a requirement from ISO 262 to review almost every work product that you have. So how can you do that in SystemWeaver? And how can you set up a safety case, which discusses generally about not only the safety of your product, but is also your organization, that your organization has the capacity to develop a safe product. So in that, what is also important is process management and having a good control over your process. So in this example, we have a workflow that is service. We have a service-oriented architecture that is implemented in this demo database, or demo company, you can say. And we're going to look at requirement management, a little bit of design as much as it is needed. And then different kind of test levels that we have. We're not going to go into how this is connected to coding and implementation level. But there are also, if you're interested, we have some videos that we can send you on how that can be done. Yes, I already mentioned these two first points. So what kind of questions are we addressing, and hopefully you will have answers to. As I already said, we're going to look through the HARA. We're going to break down the safety goals from the HARA and take a look at the functional architecture of this very simple example of an ACC feature. We're going to look at how to establish traceability between all the safety artifacts and how to argue that your product is safe. We're going to have a quick look at FMEAs and fault trees as two quite common systematic methods to for both safety and quality assessments. And also we look at the tests and reviews. So it's quite a big agenda that we have here. So let's see if we can make it. Also, we have the process documentation and how our process, the process of this kind of demo company reflects the requirements of ISO 26262. So let's see if we can jump to SystemWeaver. I hope you have some familiarity of SystemWeaver, but if not, hopefully you will gain it during the demo. You will understand the tool a little bit more. But in short, this is where we have the data in this sample project that I'm going to discuss. Here you will see some different views of the data, and here in the ribbon you can select which view you want to, from which aspect you want to look at the data. So we have different views, not only look at, but also work with the data actually. So if we go into the data, you can see the type of each data is both indicated by the icon, but since you're not familiar with these icons that we have here, you can also see the type here written in plain words as well. So we're going to look at the adaptive cruise control in this webinar. And here we have two very simple use cases that you want to activate adaptive cruise and deactivate it. So, and then we have one actor that is called driver. As you see here, we can show a use case diagram. And what is also important to know about SystemWeaver is that the data is always the center. It's never the views that are the center. So you have one source of data, which is your data model, and then you generate views based on that, as I already mentioned. But it's worth emphasizing because a lot of tools are going the other way, which means that you work and store the data mostly in diagrams, and it doesn't guarantee necessarily that the diagrams are consistent with each other. So here we're going in the other direction. So here, for example, I see I don't have an actor for deactivate ACC, so I can add the driver as an actor for the ACC, and then when I go back, I see, okay, this looks a little bit better. I'm not going to develop the data so much, but rather show you already what data I have put in here, because we don't have so much time in this webinar. So based on these use cases now, what we want to do is to set up some feature requirements. So one such requirement is that we want to, I go to the overview so you can see the text for the requirement. It's very simple example, but here you can have the description of the requirement, you can have pictures and everything else that you want to describe the requirement. And then you can also establish traceability to the use case that we were discussing, activate ACC. And once you have describe. So this would be an input to your safety safety analysis now. And on this level, what we want to do is to look at the totality of these feature requirements and do a hazard analysis to see what kind of safety goals we are required to implement in order to have this functionality in the car. So that you will do here in the hazard identification area for ACC. The first step you want to do here is to look at these requirements that you have and see in which way they can be hazardous. So in this company, what they do is, or what we have set up here is that we have these, we're using this HAZUP methodology, which means that you have a certain number of guide words, in this case 6 guide words that are quite common for many companies. So maybe you already know these guide words. So you cross these guide words with the requirements that you have here to see, for example, if loss of activation of adaptive cruise will put the vehicle in a hazardous situation. So for this, we have a view. I can click on this. So you see on the rows, you see all the requirements that are listed here. And on the columns, you see the guide words. And then you can see in each cell, in 3 of the cells, we have argued that this is hazardous, that unintended activation of the cruise control might be a hazard that we need to address. And you can also create new hazards here in the cells if you need. And you can say that this is not applicable. I'm not going to go through all the details of the views, but the important thing is that this view helps you to argue that you have some completeness in your analysis and you don't miss anything in this sense. So once you have, you see we have 3 hazards, and maybe you notice when I click not applicable here, it will appear in the data model. So although we're working in a view here, but the reflection comes in the data model. And this data model follows a meta model that we have set up for this example. So all the rules of what you can create and so on in each context is coming from the meta model. Okay, so here we have now 3 hazards. So the next step would be to look at these hazards in different situations to see how severe, what the impact of such a hazard can be in different situations. So for more advanced ADAS and AD functionality, you have a richer situation space that you want to take a look at. But for a classical kind of functionality, you can say, then maybe it is enough that you have a certain predefined hazardous or a situation that you say that we only analyze each hazard in these 10 or 15 situations. So if you choose that methodology, then we have this other view, the hazardous events, where you have, now we have the hazards on the rows and the situations, these 4 situations that we have defined will be the columns, and you can, like we did with the hazards, then you can say whether a hazard in a certain situation will be risky enough to be an ASIL classified or not. And in this case, I have only created 1 hazardous event, but I can also say that this hazard in this situation is not going to create any problems while you're driving. So with this step, then what the outcome of this step would be what we call hazardous events. where you can also, as you see here, so down here you have the same data that you have here, but represented as a list for you to be able to add some additional attributes, for example, severity, exposure, and controllability, and some argumentation you can add here. And once you have done that, then you will get a ASIL level for each one of these hazardous events. And then what you need to do is to, we can go to the next step, which would be a list of all the hazardous events. Here we have a hazardous event that is classified as ASIL C, and then you can work here and create a safety goal to address that. You can actually do all of these things also in the tree view here, but I'm showing you some of the views as well. And once you have done these, you can also work in a more Excel-like or a grid-like view, where you see now the safety goal that we defined for ASIL with ASIL C integrity, the hazardous event that we had defined, and you see that they're connected to each other, and also which hazards would cause that hazardous event. And here you see that you have two hazards that you haven't analyzed further. So that is something that you need to do before you're done. You can also look at the data graphically, where you start from these requirements that we started. We had 3 hazards, and then we created 1 hazardous event, which is connected to this hazard, ASIL C, and then the safety goal. So when you have this kind of a data model, then you can create many different views as you like. So this will conclude our part with the HARA, and the outcome of that will be a safety goal. And then you have also the rest of the feature, ACC feature, with all the requirements and use cases. So what you want to do now is to take a look at a more detailed functional description of your feature. So in this case, what we do, now we have another area for feature realization or functional architecture. In this area, we have the adaptive cruise control as one of the areas. We have also lane keep assist and other features that can be here. So we have received now this adaptive cruise control feature. You see it's a feature now as an input that we need to implement and we need to trace to. So we need to make sure that the requirements that we are receiving from here, plus the safety goal, has been fulfilled in our functional architecture. So if I now go to the functional architecture itself, then you can see, I told you this is a more service-oriented architecture approach. So we already have some services in our company, like a radar or a camera or HMI and so on, that we want to interact with from the ACC feature, because the ACC feature itself doesn't have, doesn't own kind of the sensors, but it and the actuators, but it rather sets requirements on them. So this is a way to represent that, to look at these as services or capabilities, actually. So in this example, capabilities are high-level services, abstract services. So you see you have a functional architecture like this, where and then you can define what kind of needs, what kind of data you need to get into your ACC control unit. And also you can define requirements and safety requirements. So in this case, I have defined one safety requirement, and I will show you how this safety requirement came about. So there is one safety requirement on the ACC control unit, which is of ASIL C, and it is there to make sure that we're complying with the safety goal that we just created. So we have a safety area, or actually an analysis area here, where you can do safety goals. You can do fault trees looking at how a safety goal can be violated as its starting point. And you can also do FMEAs. So if we look at now this fault tree, the root of that is actually the negation of the safety goal. So we look at how, if you remember, the safety goal said that we shouldn't have unintended acceleration. So if I open it here, the system shall prevent unintended. You don't see the rest of the text, but it says unintended acceleration. So in this case, then we have only identified two events, and we're going to go deeper into this error in engine throttle that might lead to unintended acceleration, and we have some other elements. So now, if we look here to the root of this, we have connected our safety goal to the root of the analysis, which means that the this fault event that we have here is the negation of the safety goal. And then we have this error in engine throttle and the other event that we have here. So what we need to do now is to make sure that we have a requirement in our functional design that makes sure or handles or mitigates or detects error in engine throttle. And that is the requirement that you saw in the functional architecture that we saw a minute ago. So also, if you look at that requirement is also setting constraints on one of the interfaces that you saw in the functional architecture. It sets requirements on the engine error. And you can see also that we have a safe mode, which is disabling ACC will take us to a safe mode for this, both for the safety goal actually here, and also on the functional safety requirement that we have defined here. So if I now want to look at the totality of the analysis, I can go to the safety graph here. Here you can see the fault tree analysis. You can see the safety goal that we started from. Then you can also see what requirements do we have in order to prevent the kind of leaf fault events to happen. And you can also see the connection between that requirement and the signals, or actually in this case, interface that we have on this level. So this gives you an overview. This is one way of showing the overview of this functional analysis that we're doing here. Another way is that you can, given the same model, you can generate a document called functional safety concept, where if I generate this document now, so it goes through the functional safety data. You see here, it's based on the feature realization adaptive cruise control, and it will generate a 10-page document where you have some introductions here about your general safety concept. And then you have more specific, I need to zoom in more here. So this will give you a context diagram of the function and the fault trees, and also what requirements you have. Here is a list of requirements that we just saw earlier. So in table format, and then also the requirement text and requirement ID, ASIL, and so on. So this will be the functional safety concept in this case. I don't know if I'm, maybe for some of you are very familiar with this, and some of you are seeing this for the first time. So I hope the pace is reasonable for those of you who are not familiar with the model so much. So I will carry on, and if you think I'm going too fast, then you can stop me. You can write something in the chat. So once we have done this, the functional architecture, then because usually you have many different features that need to kind of cooperate in one system. And in this case, we have defined a system. This is not a usual definition that you kind of have a system called ADAS. Usually you break it down into smaller pieces, but for this example, we have created a system called the ADAS system. And if we look at the design of that system, now these are the more, what we saw earlier, it's a conceptual and initial or preliminary design that as ISO 26262 calls it. And this is the more actual design in a specific project. You see you have more specific names for the signals, which in this case, it's not exactly one-to-one mapping with the interfaces, but it's quite close. But in a more complex system, then you would have many signals connected to one interface, and maybe not all the signals are interesting on a conceptual phase. So you might have new signals here as well. So what we have received on this level, you can see that we have received the ACC control unit as an input. So we need to make sure that our final design respects all the requirements that we have under the ACC. Here we sent two requirements, one safety requirement that we just defined in the fault tree, and then we have an additional requirement here as well. And we have the interfaces of the ACC functional design. So this would then be a design architecture. And in this meta model, I have set up both an adaptive and a classic AutoSAR model, but we don't need to go so deep, or we don't have time to go so deep into the allocation of these design elements onto hardware. But I can show you a quick example. This will be a little bit larger example than we have seen so far. So this, if we look at just the part below here, you can also see how these software components are allocated onto the different ECUs, and how these ECUs are connected with, and these are buses. This is a CAN bus here, and here is another CAN bus. So you have two different CAN buses connected with a gateway in between. We have another example here that is more a mixture of a classic design and an adaptive design, and how they interact with each other. And then in that case, you have both classic ECUs, and then you have machines as well, virtual machines or physical machines, which is more common in the ADAS and AD world, actually, to work in this way rather than with the classic ECUs. But we don't need to go deeper into this. But what is good for you to know is that we have now received if we follow through with the example that we had, so we had the functional safety requirement, and that would be, so what we need to, this was the incoming functional safety requirement from our functional architecture. We do another set of fault tree analysis. And here you see we have also done a ASIL decomposition. So we have a watchdog functionality with ASIL A, and then an engine throttle error shall be handled. This is a requirement that we set on the engine control unit. And this is ASIL B. So here we have done an ASIL decomposition, and the argumentation for that can be also made, or the documentation can be made also here. So if I go to overview, we have, let's see if I have filled something here, not on this level. Yeah, so you can do safety argumentation here as well for why you think the ASIL decomposition, why you think you have, or you actually argue about the independence in your design between the watchdog and the other units and so on, and which enables you to do decomposition. Of course, you can have more elaborate ways of arguing for safety as well, which I haven't set up in this database. Drinking a little water. Okay, so let's see. And on each of these levels, you're depending on the process that the company chooses, you can also do an FMEA, and we have a FMEA view. The data here is dummy data, but you have an FMEA view that you can you can do a complete FMEA analysis, and it is also connected to the issue management system, change management system in SystemWeaver, so you can follow up on the FMEA issues that were created or actions. Maybe we don't need to go so much in detail here because we have some other things to talk about. One other thing here is then we have looked at the system design and partly on the software design with the software components. So we have looked at that. What we haven't looked at is the hardware design. So here we have a model that enables you to do a hardware design, which will usually look very large. But here we have a trimmed down example. Let's see if we can generate a graphical view of that. Now you see it's a lot of data here, so you need, you can navigate it in different ways. Maybe this view will be a little bit better view, which shows you how the different ECUs and sensors and actuators are connected from a hardware perspective. And then, of course, you need to also map the signal that you have onto either if they go through the buses, we have support for that, but also sometimes maybe they go through the regular wiring between to the sensors and actuators. So that possibility is available here. And what is also interesting usually here is that you want to do an FMEA to see what happens when you lose one of the components. Then you can do an FMEA, for example, here. The EBCM ECU, what happens if you get a short circuit and because of water leakage and so on, then you can set this up here and get an RPN value. So we have quite a wide scope here, but I try to just walk you through the flow of data, and then there's a lot of details, of course, here. And what is also important to know is that these all of these activities will not be done by one person. It's going to be spread out depending on how the roles in the company are defined. And usually these are very large projects that go over many years of development. So in the end, the data set here will look much larger than what you see here. And since it's a collaborative environment, it will be developed in many, yeah. Okay, Lars is asking to see the safety case. I will show that in a minute. Yes. I don't remember the sentence that I just dropped here, but I think I said what I wanted to say here. So there is more detail to this, but we're going through the kind of the main flow of data. So we showed the documentation here as well. For functional safety concept, another document that, or another aspect of this is also the safety case. So for this, we have implemented the GSN model, graphical, I don't remember what it stands for. This is notation, graphical state notation, or safety notation. I don't remember exactly. So here is where you argue about the totality of your function for why you think that both technically you have done what needed to be done, and that you have verified what you have done, that you have covered, you argue about completeness of what you have done. You argue that you have reviewed all the work, and you also argue that you have sufficient processes in place in your company, and also that you have good competence in engineering competence in the company, and that you have had good training and so on to kind of to increase the what is the word I'm looking for? Not validity, but increase the trovärdighet, credibility of your solution. So here you see also I'm pointing out a process model, which is another thing that you can capture in SystemWeaver, which is, in this case, we have defined the flow of the flow that I went through with you now. We have defined it in this way as well. So actually I can show it in a different view here. So this is the same process that I was pointing to in the other tab. It's available here. This is a graphical view of that. So we went through the feature definition, we went through HARA, feature realization, we got the functional architecture, functional requirements, then we did the design level, and implementation and hardware and AutoSAR, and then we go back up the V model. I haven't shown you yet the test model. I can show you quickly here. If I go back to our main structure, so here we have 4 levels of testing that we're doing, and the idea here, for example, for functional testing, is that you want to have ideally 100% coverage of all your requirements. So you want to have a test case defined for each requirement, and then for each delivery you want to also capture the test result in that delivery. And this is just a preview of that. In this case, I have only we had 3 requirements in this function in the cruise control function, and we have only made 1 test case. I can click here and see exactly which test case that is. So we have this engine throttle error test here, where you can also specify the test if you go here. And there is also traceability to the safety requirement that we had. And 2 of our requirements are not covered by by test cases in this example. Yes. So the ASIL level. So once you have set this up, then you can you get a nicer view of, for example, if I go here on our entire unallocated design, then you can set a list of, for example, in the ADAS system, we had 3 requirements. These are their ASIL values. These are the requirement IDs. And then you can see also the traceability upwards to the functional design. What kind of incoming requirement in this case means the functional requirement, and what was the ASIL level of that, what kind of test cases you have connected to them, and so on. One thing that I didn't show is how you work with reviews. So we have support that everything you do, you can also perform a review on that. And this is connected to the change management system in SystemWeaver. We have also integration with Jira, where you can create tasks that need to be performed in the review. I can show you an overview for this ADAS system. So we have a safety review that is happening for the ADAS system, and we have a technical review. So if I open the safety review, so there was a main task review FMEA with a certain number of underlying tasks. And you see the status here and the task status as well. And then we have the technical review as well, in addition to the safety review, which might have different criteria depending on the process in the company. Actually, if I move this down, then you can see an overview of the entire thing as well in one go. So this was about review. About the safety case, I think I interrupted myself there. I go back to the safety case, and here you can see a graphical view of the safety case that I was discussing. So you always start from a kind of a root goal that you want to argue that the control system is acceptably safe, and then you have underlying arguments like that you have identified hazards and so on, and that your development process is compatible with ISO 262. And here you can actually point to the process that we had that I showed you in the other tab. If I click here, you see, and then it is highlighted in green that you are actually pointing to an actual artifact and data. And then you have this development team has adequate competence, which you might want to write a few pages about that for why you argue like that. So this would be the safety case, and then you can generate this as a document, of course, as well. So I hope Lars is happy. Does he say something? Okay, if we can share the sample database. Sure, Marcus, I think it would be good if anyone has a question like this to contact us. Then we can share all the data and maybe even have a demo session. And I think this walkthrough was a bit quick, so maybe you get lost if you're not very familiar with SystemWeaver. But you're welcome to contact us. And Marcus, sure, we can share this with you. One other aspect, we talked about the process definition here. And it looks a little bit shallow here, but then you can actually double click and go deeper in the process. I think it didn't like that I changed tabs so much. Let's see. So here, hazard analysis, then you can see also that even under each one of these steps, you have more depth. So actually, we went through these steps together. We investigated potential hazardous events, defined safety goals, and so on. and then you can stand actually on each one of these. There is more detail. You can specify which role is responsible to perform each one of these steps. And you can also see more, you can put screenshots and other data as you want. So this will be a complete kind of a process report for your company that you can distribute like this. There is more detail here, but I don't think it will be interesting now in these 5 minutes that we have left. Instead, I want to take a step back and see what we have missed. So if we now look at, we had this process definition here, and we have the ISO 26262 and ASPICE and other standards. So maybe one important question that you want to ask is that, for example, if we're looking at ISO 262, then you want to see what steps or what in this, for ISO 262, you want to see what are the requirements from the standard, and what kind of internal process steps do you have in your company to address each one of these chapters, what kind of work products you have that will address these questions, and so on. So in this case, you see that there is a gap here between, so we haven't addressed these parts of the standard in our company. It could be because it's irrelevant for us. It could be because our process documentation is not complete, which is the case right now. I haven't made a complete process description and connected them to the standard. Otherwise, I think we covered a lot of these requirements. I don't know about all the details now, but we can look at this later if you're wondering about something. But this is a good tool that visualizes, in case you have an assessment or something, that visualizes what kind of activities you have for each one of these requirements in the standard. We have 4 minutes left. Yeah, the tool qualification. In this database, I don't have any model set up for tool qualification, but we have a model to describe a tool chain, because the tool qualification is valid in the scope of a tool chain. So you need to describe your tool chain, and then you need to look at what kind of errors might occur as a result of some error in a tool, and then what the consequences will be. And out of that, then you will get a TCL value for that tool that the tool needs to comply with in your tool chain. And then you can write the tool qualification based on that. Sometimes, I mean, if you're asking for SystemWeaver, yes, we have a document which argues about the qualification of SystemWeaver, and a lot of the times you can see that some tools that say that they are qualified, or they have a stamp that they're certified for ISO 26262. But that is quite a shallow argumentation, I would say. But each company needs to actually certify their entire tool chain, and we have a meta model for that in case there is interest in that. So it's not in this database, that's why I don't share it right now. Do we have any other questions? Any more standards that you have applied? Yeah, so we can also look at ASPICE. I haven't made all the connections, but here are all the ASPICE based practices that I have received from that you can get from ASPICE. And then here you see I haven't made all the connections yet to ASPICE, but the possibility is there. And then once you have done all the connections, then you will see that what gaps you have, or where you have where you have kind of systematic problems in your company. Any more standards? Yeah, I think we answered all the questions as well as we went through. So, and we're running out of time as well. Sorry that it was a little bit rushed, but we had quite a big scope, and I'm very happy also to follow up with anyone who is interested about either the totality or any specific aspect that we discussed here. Hope it was understandable for you guys. Yeah, if there are no more questions, thank you, Lars. If there are no more, Lars, you're already an expert in this, I know, but thank you for your patience. Thank you everyone. And so we try to make the recording available as well. Thank you very much. Thank you. Have a good day or night for some of you. Bye-bye.